Okay, so in this problem, it says a circle A is inscribed in a triangle as shown. And so when you take a piece of information like that, you need to know what that means. And it means one thing very important, and that is that you have three pairs of congruent legs, or congruent parts of these triangles. That is just a theorem. When you got two tangent lines, they are the same distance away from the circle from the point where they intersect. So a very important theorem. And if you notice, what that also means is that EDC gives you an isosceles triangle, which is very valuable. You're also given that angle F is 72. And then angle arc DG is 126. So you have to figure out what to do about this. Well, we haven't, there's a couple theorems that you can use to solve this problem. But one is recognizing that if you draw this in, these two radius, that means that these are 90-degree angles, which means angle EAG and angle F are supplementary because it's a quadrilateral, and you got two 90-degree angles, which means the other two angles must add up to 180. And so angle A is 108, but angle A is just an central angle, and so that means arc EG is 108. And it turns out anytime you have two tangent lines from the same point to the circle, these two angles will always be supplementary, which means if this is 126, this is 54. And then there's a couple ways you could do it from here, but if you look at the big triangle, if this is 54 and this is 72, well, you just do 72 plus 54, which is 126, which means that 180 minus 126 lets us know that that is 54. And it turns out that this is 108. And so if we look at arc ED, well, we just found out that it's 108. And angle CDE, well, we don't know it yet, but we take advantage of this being a isosceles triangle. This isn't 108, it's 126, not 108, because it's supplementary, and so we said that wrong. So DE is actually 126 and not 108. And then, since this is an isosceles triangle, this angle and this angle are congruent to each other. So 180 minus 54 is the 126. Divide that by 2, and that gives you that CDE is 63, because we just take advantage of the isosceles triangle theorem. And finally, at once EG, which we found out at the beginning, is 108. So that tells you all three of those values. And interestingly, it ended up with a very large, based on the values, isosceles triangle, even though it didn't look like it, which you always remember in geometry, never trust the figure.